Okay, this is page 357 in your textbook. Today's lesson is on sequences, specifically arithmetic sequences. A sequence is an ordered list of numbers. Each number in the sequence is called a term. In an arithmetic sequence, each term is found by adding the same number to the previous term. So basically, when you start counting by numbers like 2, 4, 6, 8, 10, or 3, 6, 9, 12, you're actually creating an arithmetic sequence. But it's not just that. Take a look at this. 1, 3, 5, 7. What would come next? 9 would come next. We're counting by twos, but we didn't start with 2. We're counting by twos, but we didn't start with 2. Take a look at this. 1, 1.5, 2. What would come next? Well, it would be 2.5 followed by 3, followed by 3.5. It says words. Describe each sequence. The first one we were adding 2, and I already said that. Here, what are we adding? We are adding 0.5. We're adding 1/2 to the previous term. In an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. Look at example number 1. Describing the relationship between the terms in an arithmetic sequence, 8, 13, 18, 23, etc., etc., then write the next 3 terms in the sequence. Well, you can see here in their example that going from 8 to 13, 13 to 18, and 18 to 23 is going up by 5 each time. So since we are going up by 5 each time, we can add 5 to 23, which gives you 28, and then add 5 to 28, which gives you 33, and then add 5 to 33, which gives you 38. So the next 3 terms would be 28, 33, and 38. I also want to point out the pattern in the numbers. 8, 3, 8, 3, 8, 3, 8. Because we're going up by 5s, you have a repeated number in the ones place. So even within the general pattern that we're seeing, there is a smaller, more specific pattern as well. Take a look at example number 2. It says 4/10, 6/10, 8/10, 1.0. We're going up by 2/10 each time. My suggestion to you on these ones that have decimals, kind of block out the decimals for a second. If you do that, it says 4, 6, 8, 10. What would be the next one? Well, you would say 12, then 14, then 16. We're really just kind of counting by twos, but because the decimals are there, I need to go back and place the decimals in. So it's 1 2/10, 1 4/10, 1 6/10. Don't let the decimals throw you off. Just kind of block them out to begin with. Think of them as whole numbers, and then go back and add the decimals in. It makes it a whole lot simpler. So go ahead and try letters A, B, C, and D on your own before going on to the next set of examples. Here on page 359, it wants us to take a look at sequences a little bit different. It wants us to come up with algebraic expressions that will describe the sequence. In a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8. The 2 is in the first place in that sequence. The 4 is in the second place in that sequence. The 6 is in the third place in that sequence. And the 8 is in the fourth place in that sequence. If I wanted to, I can now turn this sequence and my numbering into a table. And you can see down here at the bottom, they have done that where the position is the top line here, and the term is the right-hand side, or the bottom line up at the top. What they have in the middle is what you would do if you took the position number, did something to it, to get the value of the term. And in this case, you would multiply 1 times 2 to get 2. You could also multiply 2 times 2 to get 4. You can multiply 3 times 2 to get 6, and 4 times 2 to get 8. So what would you do with the position, the top line up here? What would you do with the position to get the term, the bottom line here? What would you do to the position to get the term? That's what we're looking at when we create an algebraic expression. Okay, let's take a look at example 3 now. This is still on page 359 in your textbook. It says, the greeting cards that Meredith makes are sold in boxes at the gift store. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? What is the total? So what we would like to do here is we would like to make a table where we can have 2 columns. The first column, the X column, would be the number of weeks. So hashtag weeks. And we would have then a Y column, and I'm going to leave a space in our table to come up with a rule. We're going to come up with a rule here. So let's put a rule in here. And then the third column, the Y column, would be boxes sold. Okay, you don't need to concentrate on making your table super neat. Just make a table with 3 columns, with an X column, a rule column, and a boxes sold column. So it says in the word problem that the first week they sold 5 boxes. So week 1, 5 boxes. Then it says the pattern continues. They sell 5 more boxes each week. So the second week they would have sold another 5. That would give them a total of 10 boxes sold. The third week they sell another 5 boxes, so that would be 15 boxes sold. And then the fourth week they would sell another 5 boxes, and that would be 20 boxes sold. So you need to quickly draw your table. Now, what we want to look at is, what are the patterns? As we go up from week to week, we are going up by 1. So we're adding 1 to each week. That means basically our numbers are going in order. The Y column, they're going up by a different amount. Well, since they're selling 5 boxes each week, it's easy to see that they're going up by 5. This is the pattern, okay? This is what we are adding to each new term in our arithmetic sequence. This is not the rule. Adding 5 is not the rule. To come up with the rule, we want to know what we're going to do to X. We want to know what we're going to do to X to get Y. And I'm sorry, I put that X in the wrong place. What are we going to do to X to get Y? Well, if X is 1, or X is 2, or X is 3, or X is 4, we're going to ask ourselves, what would we do to this number to get that number? Well, one thing I could do is I could do 1 plus 4. That would give me 5. Or the other thing I could do is I could multiply by 5. 5 times 1 gives me 5. Well, both of those would work for the first term. So I'm going to look at the second term, and I'm going to try both. I'm going to say, okay, well, what if I added 4 to 2? 2 plus 4 is 6. That doesn't give me 10. 3 plus 4, that's 7. That doesn't give me 15. And 4 plus 4 is 8. That doesn't give me 20. So I'm not adding 4. That's not my rule. So let's go back and try multiplying by 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And 5 times 4 is 20. So it appears that the rule is to take 5 times x. And we would write that up in our rule box. 5 times x will give me y. So when we go back to our word problem and it says, hey, how many boxes would they have sold by the end of the 100th week? We can add another column, or another row, I should say, to our table where instead of doing 5, 6, 7, 8, 9, 10, et cetera, we can just go straight to 100 and we can apply our new rule of multiplying that number by 5, and we can do 5 times 100, and we will find that they would sold 100 boxes. So I would ask that you do it this way and write the rule. And the rule is not 5y. That's what I get when my brain's not thinking. That y equals 5 times x. Let's do it this way. We're going to do 5 times x equals y. And so 5 times 100 equals 500 boxes. So don't worry about doing this row up here. Let's do it this way.